So in this video, we're going to be looking at the big ideas for section 2.1. And we're going to start off by looking at z-scores. The first thing we want to see is, what is a z-score? What is the formula for it? Well, our informal formula at this point in time is that a z-score is the value that you are concerned with minus the mean divided by the standard deviation of the distribution that you're looking at. So it's the value minus the mean of the distribution divided by the standard deviation of the distribution. And the definition of a z-score is this. It's the interpretation, if you will, is the context is z standard deviations above or below the mean. So what we want to put right here is the context of whatever we're talking about. So if we're talking about test scores, we may say Johnny's test score is, and then whatever the z-score is goes right here. And it's important to know that a z-score is the number of standard deviations above or below the mean. So whatever the context that we're talking about is z-score standard deviations above or below the mean. And we should know, and if you want to add these notes, if you have a positive z-score, we're talking about above the mean. If we have a negative z-score, we're talking about below the mean. So now, the second set of big ideas is about shifting and rescaling. And when we talk about shifting, what we're basically saying is adding or subtracting values to your data set. Or I should say adding or subtracting a value to every item in your data set. Rescaling is multiplying or dividing. So if we multiply or divide by something for everything in our data set, that's called rescaling. So what we learned about was this, that for any given list of numbers, the shape and variability will stay the same when you add or subtract a number to each value. So if we take our data set and we add or subtract a number to every single item in that data set, then the shape and the variability are going to stay the same. But the center will shift up or down depending on the value that is added or subtracted. Well, that right there, all of this is shifting. Addition and subtraction is shifting. I'll draw a little arrow here. So this right here, adding and subtracting, we're talking about shifting. Now, what about rescaling? When we say rescaling, we're talking about multiplying or dividing. So if I change colors here, rescaling, if I come all the way around to here, is multiplication or division. And if we multiply or divide by the same number, but if we multiply or divide every data point in our data set, the shape will stay the same when you multiply or divide. But the center and the variability or the variation will change by whatever you are multiplying by or whatever you are dividing by. So for addition and subtraction, shape and variability stay the same, but the center will adjust. For rescaling, which is multiplying and dividing by something, the shape of the distribution stays the same, but the center and the variability will change by whatever you multiplied by or whatever you are dividing by. And the reason why we're even bringing up shifting and rescaling is because that's what we're doing when we find a z-score. We're shifting by subtracting the mean from every data value, and we are rescaling by dividing by the standard deviation. And one of the last things that I'll talk about here is that this is called standardizing your data. Okay, this is like little bonus material even in the big ideas. This is called standardizing the data. And when you standardize the data into a z-score, what you find is that the mean will be equal to 0 and the standard deviation will always be equal to 1 when you standardize the data. So by turning it into z-scores. So there's our big ideas. Hopefully this helps you understand a little bit better, and hopefully you have a great day.